What if I told you the future of our cities isn't all about shiny new steel and glass? What if it's actually about rediscovering ancient secrets? Today, we're diving into how the world's oldest building materials are getting a high-tech scientific makeover to create a totally sustainable way for us to live. You're going to want to see this. Okay, let's just start with this number, 82%. That is how much energy we could save by switching from conventional building materials to natural ones. We're not talking about a small tweak here. This is a complete game changer. So how on earth is that even possible? Well, the answer comes down to a really important distinction that honestly most of us get wrong. First up, let's unpack something called the sustainable paradox. It's all about figuring out what these buzzwords we hear all the time actually mean for us. And here it is, the heart of the paradox. We throw the words energy efficient and sustainable around like they're the same thing. But they're not even close. See, energy efficiency is just about using less power. Simple. But sustainability, that's the whole picture. It's about where the materials came from, its impact on the local community, and what happens to it when the building's life is over. So yeah, a building can be super efficient, but still not be truly sustainable. And this is exactly why this conversation is so critical. Our buildings, our homes, our offices are responsible for more than a third of all global emissions. That's huge. So changing how we build isn't just some nice eco-friendly idea. No, it's absolutely essential if we're serious about getting to a net zero future. All right, so how do we actually do it? Let's get into the really cool part, the science of smarter building and the new generation of materials that are making all of this possible. We are talking about some truly incredible stuff here. Mycelium, which is basically the root system of mushrooms, can be used to create bricks that are not only biodegradable but also fire-resistant. Insane, right? Then you've got bamboo, which grows ridiculously fast and has super low embodied energy. That just means it takes very little energy to grow it and turn it into a building material. And then there's cross-laminated timber, or CLT. This stuff is so strong you can build skyscrapers with it, and it literally acts like a carbon sink, locking away carbon for the entire life of the building. So how do these materials actually work their magic to slash our energy bills? This right here is one of the cleverest tricks in the book. Phase change materials, or PCMs. Just think of them as a smart battery for your house, but for temperature. During the hot part of the day, they soak up all that excess heat, literally changing from a solid to a liquid to store it. Then, when it cools down at night, they release that heat back into the room, keeping the temperature perfectly stable, all without you ever having to touch a thermostat. And make no mistake, this isn't just happening in a few isolated labs. This is a global effort. This map shows you how researchers all over the world are connecting the dots. You can see the clusters, right? Energy efficiency in red, sustainable development in blue, and new materials in green. Look at how they all overlap. It's proof that the smartest people out there are working together to solve this problem from every possible angle. Now, this all sounds great in a presentation, but is it actually happening out there in the real world? Okay, let's go from the blueprint to reality. What we're really seeing is this amazing journey from old to gold. We're taking the traditional wisdom of building with local, natural stuff like wood and earth, things our ancestors used for centuries, and we're supercharging them with modern science. The result? Materials that actually perform better than the conventional stuff we use now. And here is the proof it's not some far-off dream. Just look at Indonesia. In Jakarta, there's a 16-story office tower built with that cross-laminated timber we talked about, and it saved an estimated 7,000 tons of CO2. In Bali, they've actually built expo pavilions out of those mushroom composites, and all across the country, bamboo is being used for the structural framing of everything from luxury resorts to local schools. It is happening right now. So, what's the big takeaway here? The most important thing to get is that this isn't just about swapping out concrete for wood, it's a fundamental shift in thinking. It's about creating a circular economy for our buildings. I want you to imagine a future where buildings aren't just demolished into a pile of rubble. Instead, they're carefully disassembled, where every single beam, panel, and brick is designed from day one to be reused or recycled. That's the real endgame here, to eliminate waste completely. This revolution is really just getting started. So I want to leave you with a question. Which of these mind-blowing future materials are you most excited to see? Is it A, entire buildings 3D printed from living mushroom bricks? Or is it B, a new kind of limestone that literally pulls CO2 out of the air as it grows? Let me know. Drop an A or a B in the comments below.